Limits means I'll write CL as confidence limits. X bar plus or minus that T alpha by 2 comma n minus 1 into standard error. If I multiply that X bar, that is 127.33 plus or minus 2.04523 into standard error is 4.171 something you get. If you multiply, it will be something around 8. So you get two values. That lower bound value, lower confidence limit will be 118.8 and the upper confidential limit will be 135.86. I think now is it clear for you how we got the confidence limits?
This is the 2 sigma level.
Yeah, two-tailed test.
Considering 5%, considering the confidence of 95%, at 95%.
Yes, at 95%. Now you have a doubt.
See your T value of 0.025 and the level of significance, the degree of freedom of 29 we have considered. That is how we have done it. The T value
Number of values is 30, sample values.
n minus 1 will become the
29. 30 minus 1 is 29.
So the degree of freedom DF is 29 here. So you are taking out the T value for 29 DF and 0.025 value of alpha, right?
Yes. Alpha by 2.
Alpha by 2 when we do 0.25 on the degree.
Yeah.
So that is how you will refer the table and you will take out the value.
Yes.
With the standard error when you multiply your mean, that is how the equation is fit.
Yes. Now you will have one more easiest way of finding the T values. You can go to session 1. You had opened an Excel file, right? Or you can open any Excel file for that matter. Blank Excel file. Any cell for that matter. You can say equal to, the moment you say T, you get so many formulas. In that you can select T inverse. Now you have probability comma degree of freedom. Whenever I use t-test to find out, you need not go for the tables and work out. You can use the Excel sheet and find the t value. Please make a note of this. T-test, t value, the T alpha by 2 value. Am I clear? You can go to the Excel sheet, equal to T inverse, comma probability degree of freedom you will get. You got? Everybody have got that? Equal to T inverse. There you need, normally in the Excel sheet it takes two-tailed test only. So it will divide on its own. 0.05 comma 29. What you got?
2.0.
That is the value. Suppose you have a doubt. Now you will get a doubt. What if we have one tail? One tail. What will you do? So if it is two tail, you will write it as 0.05, 29. One tail, how will you do? Into 2. Make it 0.1, 29. If it is two tail, the software takes care of it dividing by 2. Correct? It becomes 0.025 on its own, comma 29, you will get the t value. Is it right? Single tail 5%, you cannot write 0.05. So into 2 will become 0.1. Again it will be dividing by 2, it will get 0.05. You get a single tail value. Got the point? Understood? Everybody understood? No? In the Excel sheet, this is purely for Excel. T alpha by 2 is taken as T inverse as 0.05, comma 29. This is for Excel. Two tail. But if it is one tail, you can, it is still alpha by 2 only, 5% will be 0.01 divided by, 0.1. Is it right?
0.05 raised to 2.
Yeah. 0.1 by 2 will be 0.05. So it will be taken, you have to take it as 0.1. 0.1, comma 29. This is only for Excel, no? If you want to find the values. Think I made my point clear?
Sir, when we apply the one tail test and two tail test,
That depends upon the data again. Hypothesis. Hypothesis. How you frame the hypothesis, that will be taught to you by Vinod sir later.
One tail is, I think, the confidence level will be less.
No, not like that. Your critical value is the term which will be spread over for two tails. If it is spread for one tail, it is one tail test. It's spread for two tails, it is two tail test. I will conclude. Sorry, I think Vinod sir is getting late for the next session. There are two normality tests. One is Kolmogorov-Smirnov test. This also you have the details there. Test for normality. If it is less than 0.05, the test is said to be normal. That's all. That point you can make a note. You need not go to the greater details of it. Less than 0.05, that is 5%, the test is said to be normal under Kolmogorov-Smirnov and Sharper-Wilks test. Test of normality, if it is less than 0.05, test is said to be normal. Sorry, greater than 0.05, the test is said to be, the distribution is said to be normal. The distribution is normal if it is greater than 0.05. What you have got? 0.13. Is it greater than 0.05?
Yes.
Test is normal. Is significant. Yeah, greater than 0.05. I think I'll conclude with this. Something called as line chart. You can read this, you will enjoy. It's a simple diagram against two variables. The example is knowledge and time. Wonderful example. Thanks to Vinod sir. After a discussion with him, he shared with us this chart. It's a wonderful thing. Time charts is basically used like your stock per week, how is it varying, and if you want to have for a 52 weeks, how is the stock market varying. That's a best example for your line chart. And most of the line charts you can see in the economic times indicators. Taken a lot of time. This will be after tea. Thank you.